Hello. Today I will be talking about the article I found, which is called Serving Up Some Knowledge, the Physics of Tennis, and really it's talking about the ground strokes in tennis, so topspin and slice. Um, so first we have to talk about how the ball is actually hit and the physics behind how how force is actually exerted onto the ball from the racket and how spin is created through that kind of process of hitting the ball. Um, First of all, you basically have two main forces when hitting the ball with the racket. We're gonna exclude some like the smaller forces, but the two main forces in the perfect world would the only two forces in a perfect world would be the friction force and the what they in the article call a rebound force. So basically, when you hit a ball, the racket is either curved. It's either diagonal facing forward like this or backwards. I guess you'd hit it like this, or you'd hit it kind of like this. So over or under. So if you hit it over, that's called topspin. And basically, the racket goes up. However, you have the two forces. So if this were the racket, the ball were like right here, then what they call the rebound force is the direct force the racket exerts on the ball. So if it went down straight, like completely straight, then it'd be just purely the rebound force, and it just go like this, and the force would kind of go um, perpendicular to the racket. However, there's another force, is the friction force, and that is where the spin is created. So, if you brush up on the ball, then the friction force goes up because you're brushing, and that friction force is created while brushing the ball and kind of coming into contact with the ball and going like this. And that is where the spin comes from. Um, and where the ball actually flies is really just after we do vector addition, really basic vector addition on these two forces. So if the racket's here, the rebound force is perpendicular and the friction force is basically facing up. So these would be the two forces. Then it just basically be somewhere in the middle, depending on obviously how much how much force is in the friction force and how much force is in the rebound force. Um, so that obviously dictates how much spin is created and the actual velocity of the ball. Because obviously, when you add more friction force, then you take that force away from the rebound force. Um, so that kind of leads into the next main part of kind of hitting ground strokes, and that is conservation of momentum. Um, really, when you hit the ball, momentum is found with the equation P equals mv, where P is momentum and is equal to mass times velocity. And the mass is, in this case, the racket, um, and the velocity is obviously caused by the force or how fast you actually hit the ball. Um, so, um, so this obviously stays constant. And the thing is, in a tennis racket, it's like a oval shape, and then you have strings, and these are very, very high tension strings in order to kind of maximize the power. So there's in the on the racket there's something called a sweet spot, which is basically it's basically the center of mass of the racket, and when you hit the sweet spot, that should exert the most velocity possible, and that kind of maximizes the momentum. However, if you hit it perfectly straight, because intuitively you think the best way to add the most force would just be completely straight like this, and just hit it right on the sweet spot. However, in real tennis, that does not really work because if you get completely straight, it will just fly into the fence because it will go completely straight and will actually curve down into the court. Um, However, this does help us kind of think about how conservation momentum is is involved in tennis ground strokes, because that momentum is conserved when the ball is kind of flying through the air to the other side. Um, so so that speed is just kind of conserved. I mean, it's not conserved. Momentum is, and the speed will obviously decrease because it's flying through the air. There's air resistance, and there are other factors which cause it to lose speed, or I mean velocity. However, this is just still kind of showing this conservation momentum because momentum is still conserved. It's just going. It's just changing forms. Um, and finally, I'll talk about how like the actual processes of the spin, and so it's basically caused by something what's called the Magnus effect, which is basically saying that if you hit a ball in so it basically the spin just goes in only one direction. So this is why when you hit topspin, the ball would go more kind of because you're going brushing up on it. So the ball would go here, so it rotates this way. And that is how the spin is created because as I said before with the Magnus effect, it's basically saying that it's just going in one direction. So the spin is just continuous. And same with the slice, it just be the exact opposite. But still that same backspin it's called is continuous. Um, so we haven't really gone much in depth into the Magnus effect, but it looks like an incredibly interesting phenomenon. Because it's kind of just saying if you hit it one way, then it stays that way. Um, however, the practical applications of spin are incredibly advantageous in tennis. I know from experience that most people prioritize more spin over power. So obviously, if you hit a lot of spin, then if you let it hit a lot of top spin, then it kind of bounces, and it just rapidly goes right up. And this is obviously more uncomfortable for the opponent because you have to hit the ball higher. Typically, when you hit high spin, then it bounces higher, and it's hard to hit a ball up here than it is right in your strike zone. And backspin obviously has different uses. Um, it's kind of it's to get down to their feet because it's hard to hit a ball when it's almost right at your feet. So really, the main idea is that the three main kind of physics concepts in a ground stroke would be one kind of like this vector analysis that we can do on it, which is the friction force and the rebound force, and we do vector addition to find that the final vector which is where that tennis ball actually goes. And second is conservation momentum because this velocity the mass times velocity is what the momentum is, and that is just conserved throughout the entire shot. Uh, so that's kind of how, so you can kind of leverage this power. So sometimes it seems unbelievable that uh, tennis players can hit like 100-mile-per-hour shots, because you can't really do that with just a human hand, like throwing a ball. You can't really do that. However, once you leverage kind of the weight of the tennis racket and hit it in the sweet spot, then you maximize the velocity, um, and that's how they generate such insane amounts of power. And finally, you have this Magnus effect, which is really explaining how the spin works. So once you hit backspin, so slice, sometimes you can see how the ball kind of like floats through the air. And this is because of the way you hit the ball is spinning backwards. It kind of creates like an air cushion under, because it's like spinning in a way that kind of pushes air under, so it kind of keeps it floating up. So that's just another interesting phenomenon. Um, so those are really the three main concepts in tennis, in the physics of tennis. And I hope you learned a lot, and I hope you enjoyed. Thank you.